Hello everyone, I'm Frank and welcome to Frank Puzzles. In the month of October, I'm going to be uploading two videos every day, one of the very easy to easy difficulty level and one of a average, hard, or very hard difficulty level. And this is today's hard level difficulty puzzle, and it's called Sleeper Cells by Bearded Fool. And here are the rules. Normal Sudoku rules apply. Place the digits 1 through 9 each in every row, every column, and every box. Crop key. Black dots separate cells with digits in a 2-to-1 ratio. So for example, if this was a 2, this would have to be a 1 or a 4. White dots separate cells with consecutive digits. For example, if this was a 5, this would have to be a 4 or a 6. Lines. Adjacent cells on green lines have differences of at least 5. So that's a German whisper line. So for example, if this was a 9, this would have to be a 1, 2, a 3, or a 4. Digits along a red line alternate between even and odd. So if this were even, this would have to be odd, this would have to be even, and that would be odd, etc., etc. Digits on a purple line form a non-repeating consecutive set arranged in any order. So this is what we call a Renban line. So for example, if we knew that this was a 1, we would have to know that there's also a 2, a 3, a 4, and a 5 on this line because it has to be consecutive and it has to be non-repeating. So it cannot have another 1, say, in this column or in this row. On this line, sorry. And it could not have a 6, 7, 8, or 9 because you would have to skip one from 2 through 4 to be able to accommodate that. So, yeah, those are Renban lines. 3x3 box borders divide blue lines into segments with the same sum. Different blue lines can have different sums. So all that means is that, yeah, every time a blue line is divided by one of these black lines, these 3x3 border black lines, then basically that subset has to equal the subset that's on the other side, which would have to be equal to the subset that's that's basically broken up by the box borders. So for example, we have these 2 digits would have to equal to these 3 digits, which have to equal to these 2 digits, right? Because we have the border of the 3x3 boxes cutting them into those segments. Okay, sleeper cells. Every row, column, 3x3 box, and line has exactly one sleeper cell. Oh, that's interesting. So every row, every column, and every 3x3 box, and every line has a sleeper cell. Sleeper cell has exactly one sleeper cell. It cannot have multiple. So and it has exactly one. Sleeper cells, though always appearing on the lines, are skipped when it comes to line logic. Okay, that's interesting. For example, a purple line that reads 18342. Oh, okay. This is valid if the 8 is a sleeper cell, as the digits that are not 8 form a valid purple line, right? It would be 1, 2, 3, and 4. So if this was like 1, non-colored, if this was 1, 8, 3, 4, 2, and this was the sleeper cell, then this would be valid because you would just ignore the sleeper cell. The sleeper cell basically does not count on the line for a value. Additionally, all sleeper cells contain digits equal to their 3x3 box number. Oh, that's interesting. Okay, so for the sleeper cell in this 3x3 box, it must be 1. So the 1 is in the sleeper cell in box 1. Except the 2 is in the sleeper cell in box 2. This 3 is in the sleeper cell for box 3, etc., etc. So this contains the 4 in the sleeper cell. This contains the 5. Okay, and we number it this way, yeah. So this is the numbering goes, this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9 for the boxes. So the 9 would have to be in the sleeper cell for box 9. The 8 would have to be in the sleeper cell for box 8. This would have the 7 would have to be in the sleeper cell for box 7. Interesting. And we know each line has a sleeper cell. And that's for the cases only of the lines. So for Kropke dots, I'm assuming that the value has to work for the Kropke dots, right? The sleeper cells are only skipped when it comes to the line logic, not the Kropke dots. And so those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. I'm not really sure how to approach this. Probably let's figure out where all the sleeper cells could be. Right? So we know the sleeper cell, it has to be on a line. So for this one, okay, so these cannot be sleeper cells. Let's color them blue, I guess. These could be. All 5 of these could be. All 4 of these could be. Therefore, these can't. Okay, so these, yeah. None of. We're just going to color in all the non-lines in blue. So this one cannot be sleeper. This can't be sleeper. This can't be sleeper. This can't be sleeper. And this can't be sleeper. Oh, we also know these can't be sleepers. So the sleepers, okay, and this one can't be a sleeper. Okay, so for box 1, where is going to be the sleeper? It has to be here, right? So none of these 5 can also be a sleeper. So one of these is a sleeper, and one of them's 1, essentially. And this one, it could be here, it could be here. So this one, each line has a sleeper. So this would count for this blue line or the green line. We have 1, 2, 3, 4, 5 lines here. So there's 5 sleepers in 5 columns. Therefore, these 2 cannot be sleepers. So one of these 3 is a sleeper. So this one cannot be a sleeper. So therefore, we know there's a sleeper here. So these can't be sleepers. There has to be a sleeper in one of these. We don't know which. And there has to be a sleeper in one of these. We don't know which. There's a sleeper here. So these can't be sleepers. So this can't be a sleeper. And these 2 can't be sleepers. So this is at least a 3. But that doesn't really limit very much. The Kropke dots okay, so the Kropke dots, this has to be a 2 or 4. The 4 is a sleeper though, interestingly enough. So this could be a 4 and that would be valid, and this doesn't have to be, we don't know what it is. So first of all, we know the 1s are here because of the sleeper. The 3 has to be one of these. The 2 has to be one of these. The 4 could be any of these. The 5 has to be one of these. So, the red, the sleeper has to be on the red. So this is a sleeper. So we know, okay, so we know this is 5. These can't be 5 then because these can't be sleepers. This can't be 5. So all of these cannot be sleeper. Aha, we have our first sleeper. On this line, where can it be? It can be none of these. Therefore, this has to be the sleeper. So we know this is a 2, and it's a sleeper. So this can't be, oh, this can't be 2, and it cannot be the sleeper. Therefore, we know this has to be the sleeper, one of those two. So this cannot be the sleeper. So the 1 is somewhere here. Okay, so for the green line, the 4 has to be on the green line. So this cannot be the sleeper. We know one of these is a sleeper, and it's either a 7 or 8. So the 4 has to be one of these 4. And for this set, we know that the 4 is actually in one of these crop key dot sets. So it's either 1, 2, 4 or 2, 4, 8. Those are the only possibility of having 3 crop key dots that are unique digits. So it has to be either 1, 2, 4 or 2, 4, 8. And the 4 has to be on the line. Therefore, it cannot be these. Therefore, this has to be a 4, which means it's next to a 2 and an 8. Because the crop key lines are not affected by the sleeper cell. So this is a sleeper cell, which means none of these can be sleeper cells, and this one can't be a sleeper cell. So the 5 is here. This cannot be 4. The red line's even odd polarity. So this is a 4. So these could be this could be anything here, right? We don't know what these are. This cannot be a 1. It cannot be 2. It could be 3, 4, 6, 7, 8, 9. This would have to be, it cannot be 2, cannot be 4. 6 could be here. Actually, 6 could be here too. 6 cannot be here. You could have a 1, you could have a 3, no 5, 6, 7, 8, 9. So that's possible. What we know is, So this is a 5. Okay. So this could be 1, 2, 3, 4, 6, or 8. This is also 1, 2, 3, 4, 6, or 8. Okay, so this can't be 2, which means this can't be 1. This is, okay, this is a sleeper cell. So this could be 1, 2, and this would be 3, 4. Okay, so say this was 1 and 2. This would have to be 3 and 4. So this would be 3 and 4. If it's 2 and 4, right, so then this would be 2 and 4. This would have to be either 3 and 5 or 3 and 1. So either case, the 3's here. I don't think this can be 3, right? If this is 3, okay, so yeah. So in both cases, this has to be 3. If it's 3, 6, this can't be 3, right? So if this is 3 and 6, it would have to be a 4 and a 5 with it. So that would be 4 and 5. And this cannot be 4 and 8. If this is 4 and 8, it doesn't form a Ren band line, right? You have to have 3 digits, 5, 6, and 7 to be along the. So this cannot. So we know this can't be 3. So 3 is either here or it's here. In which case, yeah, this can't be 3 either way. There can't be a 5. So this cannot be 3, 6. So we know this is 2. So this has to be 2. Because the 5 has to be in the sleeper cell. So 5 cannot be here. So this is 2. This is 1 or 4. This is 3 with 1 or 4. So this is 1 or 4. This is 6, 7, 8, 9. This is 2. These are consecutive. That's interesting. So say this is low. This would be 3 or 4. So this can never be 6 or 7, right? If it's 6 or 7, this would have to be a low. So if this is 6, 7, 8, 9, that's a high. It'd have to be next to a 3 or 4, which is not possible if it's 6 or 7. This could be a 6 because the 4 doesn't count. This is also a Renman, but the 3 cannot be here. Okay. So the 3 would have to be here, but the problem is we know this is 3, so this can never be 3. So this Renman cannot contain a 3. Therefore, you cannot have a 1 or a 2 on there, right? The 1 or the 2 would not be in the sleeper cell. So the 1 and the 2 are not valid. So this cannot be 1 or 2. So the 2 has to be one of those two, because the 2 cannot be on the sleeper cell because there is no 3 possible. So we know it could be 4, 5, 6, 7, 5, 6, 7, 8, or 6, 7, 8, 9 as the other values on this Renban. So 4, 5, 6, 7, 5, 6, 7, 8, or 6, 7, 8, 9. So 6 and 7 are both on this Renban line. So this cannot be a 6 or a 7. It could be 1, cannot be 3, could be 4, 5, 8, and 9. So that's all possible. So, oh, this cannot be 4, 8, right? If this is 4 and 8, we have a 3 that's not a Renban. That's the 3 that's not counted for the Renban purposes. But then you only have 3 other digits. And that would have to be 5, 6, sorry, 2 other digits. But that would have to contain 5, 6, and 7 for it to be a valid Renban. So again, this cannot be 4 and 8. So we know the 3's here. So this is 3 and 6, which means one of these is the sleeper cell. So this cannot be a sleeper cell. So this is 3 and 6, which means this cannot be the sleeper cell. So this has to be the sleeper cell. And that's a 1. So that can't be. This is 3 and 6. So it has to contain a 6. We don't know what else there is. It's 4 through 9, right? So this sees all of these digits. It sees 2, it sees 1 or 4, and this is the other 1 or 4, because this forms a Renban. Therefore, this has to be 5, 7, 8, or 9. This is 4, 5, 7, 8, or 9. So it could be any of these, right? So we know these 3 lines equal, these 3 cells equals these 3 cells. This is 3 and 6. One of those is a sleeper cell. So where is the sleeper cell in column 9? It has to be on this line. Therefore, this cannot be the sleeper cell. Because if it was, that would eliminate all the possibilities for sleeper cells there. Okay. So this is also a Renban line. And it has to be 7 or 8 here. This would have to be 7 or 8 here. This cannot be 2, 4, 8. It has to be 1. Oops. This is 1, 3, 5, 6, 7, 8, 9. Oh, no, 8. Right. And this can't be 8 either. Okay. So if this is high, this has to be a 9. So this cannot be 9 ever. This could be 9, though. And in fact, okay, that's... Yeah, if this is the high, that has to be 9 because there's no other possibility. It can't be 8 because 8 is already taken care of here. It can't be 6 or 7 because that would have to be 3 or 4. Therefore, this would have to be 9. If this is high, both of these are low, which means this is 1, 3. And the only one that fits is 9 again. So 9 has to be one of these. So it cannot be 9 here. So 9 has to be one of these. We know on this, how many digits are there? 1, 2, 3, 4, 5, 6, 7, 8. So on this, there are 8 digits. So you have to have 7 digits that form the REM band. And so that's 1 through 7, 2 through 8, or 3 through 9. So you know 3, 4, 5, 6, 7 are all on the REM band. Valid on the REM band. 3, 4, 5, 6, 7. So 4 cannot, 4 could be here. 4 cannot be there. 4 is either here or one of these 4. And it's not in the sleeper cell. Oh, this has to be the sleeper cell because there's nothing else for column 5. So this is the sleeper cell. And it's a 5. This can't be. Oops. Number delete. So this has to be odd or even, and then that would have to be odd or even, and then that would have to be odd or even. Whichever. So these two would match parity, and this one could not. It matches the other parity. I don't know why I keep saying polarity. It's parity. So 4 could be here or 4 could be here. 5 could be any of these. We know there's a 3, a 6, so 7 cannot be here. 7 could be any of these. 3 could be here. 3 cannot be here. Or 3 could be here, or 3 could be here. Okay, and 6. Okay. So this cannot be 2 or 3. So it could be 1, 4, 5, 6, 7, 8, and 9. So this could be 2, 3, 4, 5, 6, 7, 8, and 9. That's a lot of possibilities. So this is 3 and 6. This sees all of 1, 2, 3, 4 also. So this is 5, 6, 7, 8, 9. So this can't be 2. 2 could be any of these 4. 5. Oh, this can't be... this could be 2. So, yeah, 2 is possible anywhere here. This can't be 8, because this is box 8. So this can't be 9. Since this can't be 9, if this were 9, this would have to be 8, but that's not possible. This cannot be the sleeper cell. So that can't be the sleeper cell. One of these two is. One of these two is. We have a 7 or 8 that's skipped. So 7 could actually be here too. It just can't be the non-sleeper cell, right? I mean, right, it has to be the sleeper cell. Oh. Okay, so we know this is the sleeper cell's here, so this is 7. The sleeper cell's here, so this is 8. So this cannot be 7 at all. Right, because we know the 7's here. So either this is 7 or one of these 4 is 7. We don't know which. So this sees all the 7s on this, all the valid 7s, all the counted 7s on this red band line. So this cannot be 7, it can't be 2. It's still a wide variety. 5, 6, 8, and 9, right? So either this is 6, 1, or 3. So if this is low, if this is low, it has to be next to a 6 and a 9. So this has to be 1 then. It can never be 3. So 1 is here also. So this cannot be 1. Okay, so let's see what this is. It cannot be 1, can't be 2, can be 3, cannot be 4, 5, 6, can't be 7. No, it can't be 9, can't be 8. So no 1, no 2, could be 3, no 4, 5, 6, 7, no 8, no 9. Okay, so 7 is here. 7 is here. This can't, none of these can be 7. So this could be 2, 3, 4, 5, 6, 8, and 9. So we know the 7's one of those three. Ah, these are all taken care of for sleeper cells in these two rows. So this has to be the sleeper cell, and it's 6. So this cannot be a sleeper cell. So this is the sleeper cell, which means this can't be a sleeper cell, which means this is the sleeper cell. So this is the 9. So this is 9. This is 8. This has to be 2, 7, or 9. So this can't be 8. So this can't be the sleeper cell. And this can't be the sleeper cell because it sees this. So this can't be the sleeper cell. This has to be the sleeper cell, and it's an 8. So this can't be sleeper cell. So this is the sleeper cell, and this is 7. So this can't be the sleeper cell, right? And this is not the sleeper cell. So this is a 3. This is a 6. This can't be 7, so this is 9. This can't be 7. This can't be 8. This can't be 7. This can't be 6. This can't be 6. So 6 is one of those two. This can't be 8. And a 3 or 6. Oh, we already knew that. No 9. No 9. So this is 8. So these two add up to these two, which add up to this. It's probably 9. We don't really know. So can this be 6, 8, or 9? It could be any of those three. That's fine. So this is 8. Interesting. So that means we have to have a 1 here. So this is either 1, 2, 5. So this would have to be 5, and so this would be 5. Or it's 1, 3, 4, right? So this can't be 4. One of these would be 4. This 1 or 3. So this would have to be 5, 6, 7, 8. This can't be 6. This can't be 3. Sorry, this can't be 8. This can't be 6. This could be 3. This can't be 2 or 4. So this could be 1, 7, 2, 6, 3, 5. So this cannot be 3, which means this can't be 5. This can't be 6 or 7, which means it can't be 1 or 2. Okay. This can't be 1 or 2. This could be 8 or 9. This is specifically 3 or 5. It cannot be 1, it cannot be 9, it cannot be 7. It can't be 2, 4, 8, and it can't be 6 because of this one. This could be 1, this could be 4, cannot be 2, 3, or 5, could be 8 or 9. That can't be 8. This could be 8. It cannot be 9. It could be 1. It could be 2. So this is 2. Okay, this has to be 2. Aha. So this has to be 2. Since this has to be 2, it cannot contain a 9, right? Because 2 can only be with 8. So it could be 2 to 8 or 1 to 7. So no, all the 9s are ruled out. So this can't be 9. This can't be the 2, so that because we know the 2 has to be here, and it has to be valid for the Rembrandt line. So we have a 2, a 3, a 4, 5, a 6, and a 7. So that can't be 2. So 7's either here, here, or here, or here. It can't be 8, can't be 9, can't be 5, can't be 2 or 3, and it can't be 4. So, this can't be 2. This could be 2, but we don't know. If this is 3 and 5, this has to be 1, 4. Okay, so let's do it this way. If this is 3, 5, this is 1 and 4. So 3, 5. Oh, we know the 5 is one of these three specifically. If it's 1 and 7, this could be 2 and 5. Or it could be, this would be 3 and that's 4. So those are valid. So we know then. Okay, so where is the 7? The 7's either here, here, or here. We don't know which. Where is the 6? The 6 can be any of these four or that. The 5 could be that or one of those three or that. The 4, this can't be 4, this can't be 4. The 4 is one of these three or that. The 3 could be either of these two or one of those three. The 2 is here. We don't know whether it's a 1 or an 8. Okay. This cannot be... If this is not 1 or 4, this has to be both 6 and 7. That doesn't really tell us much. Wait. No, we don't know. We don't know anything about this. Oh, this adds up to 8 also. So there's no 2, 6. There's no 3, 5. This has to be 1, 7. Oh, wait. No, 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 no. Okay, I'm messing up. No, that... Okay, so... That works. This one does not. This is incorrect. We don't know what this is. So this is specifically 1, 2, 5, 1, 3, 4, right? But this can't be 3 or 5, this can't be 5, this can't be 4. We know the 5 is one of those three because it cannot be here and it cannot be here. So this can't be 9. It's 1 through 7. So this can't be 2, 5, or 7. This can't be 2 or 5. We don't know what this is. This is a separate line. So that's my mistake. This has to have the 1. We don't know if this has to have the 1. Okay, 1 is one of those three. We don't know what this adds up to. Can this be 1? I think this could also be 1, actually. Yeah. Okay. Right. So this line is different, so it doesn't have to have the same sum as this. So here we know the 1 is here. We don't know what else, so. This can never be 2, actually. Because if this was 2, where's the 5? It would have to be 1, 5 here, but that's not possible. So we have that. This is 3 or 5. So if this is, yeah, this could be 6, 8, or 9. That would be 1. This would be 9. That would be 3. So this would be 5. If this is 3 or 4, this would have to be 9. This is 6. This is 1. This is 3 or 7, 3, 5, or 7, or 3 or 5, which is all valid. Okay. This is 1, 3, 5, or 1, 2, 4. Sorry, 1, 2, 5, or 1, 3, 4. But this specific line is different from this line. We don't know what this line is. This is 1 through 5. This could be anything. It just can't be 6. Hmm. So 6 is one of these two. 6 is one of those three. Wait, can this ever be 6? No, right? If this was 6, okay, there we go. If this was 6, it would have to be 1 and 5 or 2 and 4. And 2 and 5 are both here. So this cannot be 6, which means we know the 6 is here. So this can't be 6. This can't be 6. This can't be 6. This can't be 6. We know there's a 6 on the line that's valid here. So the 6 has to be here because it can't be here, can't be here, and it can't be here. So this is 6. One of these two is 6. This can't be 6 anymore. We know there's a 7. We don't know where the 7 is. It could be here, it could be here, it could be here. Same with a 5. It could be any of those. 4, it has to be one. Okay. That doesn't help very much, though. Actually, does it? I think it kind of does. So the 4 has to be in this cell or one of these 3 cells, right? It doesn't see that one, though. These two don't see this one. But if this is a 4, this can't be 4, so this is 1, 3, but then this would have to be 4. So then this cannot be 4 in that case. Otherwise, it's one of these 3. I guess it's specifically here, this one can't be 4. Because this will see all 3 of these. It can't see that one, but if that is the 4, this can't be 4, and that has to be 4, which would eliminate 4 from there. This could still be 4, though. If this is 7, this could be 1, 6, or 3, 4. So that's fine. If this is 8, it's 1, 7. It has to be specifically 1, 7. If it's 9, it's 1, 7, or 3, 6. Hold on, let me pause. I need to do a call of nature. Okay, guys, I'm back from my call of nature. I did forget to pause my puzzle, but whatever. The time's whatever it is. One thing is, though, so where can the 9 be in row 9? It can't be here because of this 9. It can't be here because of this 9. It can't be on here because this adds up to 9 at most. So this can't be 9. Therefore, this has to be the 9. So this is the 9 in row 9. So these can't be 9. Where is the 9 in these settings? So this could be 9, and this could be 9. We just don't know which. This adds up to 6. So 8 has to be one of these 3. 8 is one of those 2. Okay. So let's remove all the blues because it's hard to see sometimes. We know the 7's here. We also know the 7's one of these 3. What about 6's? 6's can be here. It cannot be here. We know the 6 is here. This can't be 6. This can't be 6. This can't be 6. So we know this is 6. So this is 6. This is 6. So one of these 3 has to be 6, right? Specifically, then, that one of these 2 has to be a 6 because this can't be 6. One of these 2 has to be a 6 because none of these can be 6. Therefore, none of these can be 6. So the 6 has to be in this column. So the 6 is here, or the 6 is here, or the 6 could be any of these because we know the 6 is here. This cannot be 2, 3, or 5. So this is 1, 4, 5, no 5, no 6, 7, or 8. Can't be 8 either. So if this is even, this could be odd. And that would be even. That doesn't help much. So we know this is 8, which adds up to that. So it could be anywhere. It could be 2, it could be 3, cannot be 4, 5. It could be 5, cannot be 6, could be 7, 8, or 9. We don't know. So this is 1 through 7. It's no 3. So this cannot be 8 and 9. This could be 8 or 9. Hmm. This is 13 at most. It could be 3. It can't be 3. It could be 4. I think that's no, it can't be 4 because if this is 4, this is 1 and 3. This would have to be 1 or 3, and that can't be possible. It could be 2 and 3, right? So this is anywhere from 5 through 13 for this line. We don't really know what that is then. So this is 1, 2, 3, 4, 5. No 1 here, no 4. This is 1, 2, 3, 4, 5, 6. So no 3. If this is 7, this could be 1, 6, or 3, 4. If it's 8, it has to be 1, 7. If it's 9, it has to be 3, 6. Unfortunately, this doesn't tell us anything. Hmm. So 9 we know is one of those two. 9 could be any of these 5. 1. So this can't be 1. Can't be. We already have the 2. Can't be 3. Could be 4 or 5. Can't be 6. Could be 7. Okay. This cannot be 2, 3, or 6. So it's 1, 4, 5. No 6, 7, 8, and 9. This can't be 8 or 9 here. This can't be 8 or 9. This could be 8 and 9 and 8 and 9. Or one of these is 8 and 9 and one of those. And this one is 8 and 9. So we have 1, 2, 3, 4, 5, 7. No 5, no 2. Where is 8? So 8 has to be that one or that one. Hmm. So this is again 13 at most. Oh, this can't be 8. So this can't be 8 because of this thing. This can't be 8 because of here. This can't be 8 because of the Renban line. This can't be 8 because of this. This has to be 8. Therefore, this is 8. This is 2. So this can't be 2. We know one of these three is 2. Okay, this can't be 1, right? There's no 1 here because the 1 has to be here. This can't be 2. This one can't be 8. This can't be 8. This can't be 2. So this could be 1, 2, 3, no 4, 5, no 5, 6, we already have, no 7, 8, or 9. This is 3, 4, 5, 6, 7, no 7. Okay, so either that's 8 or this is 8. We don't know which. Uh, okay. So this is 2, 4, 8, which means 2 is one of those. Where's 9? 9 can't be here. 9 can't be here because it can't be on the Renban line. And 9 cannot be here because of this. Therefore, this is the 9. So since this is 9, this has to be 1 and 3. This can't be 1 or 3, which means this is a high, so it can't be 3 or 4. This is 6. This has to be 5, which makes this 6. It makes that 7. So this is 8. This can't be 8. This can't be 5 or 7. No 6 or 8. Therefore, this has to be an 8. So there's no 1 possible on the Renban line. So this can't be 6. Therefore, this is the 6. So there's no 6. This can't be 7. So this we don't know what it is. This is 5, so this cannot be 5. This cannot be 5. This can't be 5. So we know the 5 is one of those two, which means none of these can be 5. So this can't be 5. This has to be 5. This can't be 8. No 8. So this is 8, which means that could be either 1 or 3. This could be 1 or 3. We don't know. This is 8. This is 3, so this can't be 3. Because this cannot be 3. This is 4, 5. So 9 has to be one of these two. But still could be 1, 2, 5, 1, 2, 3, 5, 6. Can't be 1. No 3 or 6 here. Interesting. This could be 4 and 5. So this is 7 or 8. If it's 4, this also has to be 5. Okay, so this is 3, or this is 3, which means this cannot be 3. In addition, we know 4 is here, so these can't be 4. Aha. So this is a 1, 9, because so we know the 4 has to be one of these 3. And because of it is, that can't be 4, this can't be 4. This has to be odd, so this has to be even. So this is 4 or 6, which means that it's odd. So it's 5, 7, 9. This is 4, 6. This can't be 6. This can't be 6. This can't be 6. Therefore, this has to be the 6. So this is 6. There is no 6 here. We have 1, 2, 3, 4. So no 1, and this can't be 3. Okay. This can't be 4. 7 could be here, though. Okay, so cannot be, could be 1, cannot be 2, could be 3, could be 4, can't be 5, can't be 6, can't be 4 either, because one of these 3 is 4. Could be 7, can't be 8, could be 9. So no 3 here, no 1 here. Um, this could be 1, no 2, 3, 4. We already counted for 5, 6, or 7. Okay, so that's valid. This is could be 1, no 2, could be 3, 4, no 5, 6, 7. This could be 8 or 9. Can't be 9 because of this. This could be 1, 3, 4, 8, 9. So no 3 and no 1. So this cannot be 1, 3, 4 because this is 3 and 4. Therefore, this has to be 1, 2, 5. So this is a 5. This cannot be 5. This can't be 5. This can't be 3 or 4. This can't be 3 or 4. So this is 1, 2. So this can't be 1. Right. This can't be 1. This can't be 2. This can't be 5. So this is 1, 2. This is 5. This is 1, 3, 1, 3. So there cannot be a 1 or 3 here. So this is 7, 8, or 9. This is 7, 8, or 9. We have 1, 2, 1, 2. 3, 4, or 7. We don't know where the 4 is. This is 6. Okay. This could be 1, no 2, no 3, 4, no 5, no 6, 7, 8, or 9. Okay. So now this becomes 8 through 11. So this is also 8 through 11. This is 1 and 2. So this is 1, 2, 3, 4, and 7. Okay. These are odd. We have an even here. This cannot be 1, cannot be 2, could be 3, 4, no 5, 6, or we have 7, 8, and 9. Okay. We know this is... okay, so one of these 3 is 3, so this can't be 3. Right, because this can't be 3, none of these could be 3. Actually, we know this is 3, so this can't be 3. This becomes 1, 4, 8. Can this ever be 1? No, because it'd be 1, 4. Can this ever be 2? No, because it would be 2, 4 at most. Can this ever be 1? Yes. So this is 5 or 6 with 1, 2, or 4. So if it's 5, it has to be with 4 or 2. So this would be 7 or 9. If it's 6, it could be with 1, 2, or 4 because 1 or 2 because that would be 7 or 8. Huh, okay. So this is 5 or 6. This can't be 4. Because of the same issues for why this couldn't be 4. Either 4 is here, in which case it sees a 4, and so it can't be 4. Or this is 4, in which case this is 1, 3, and this has to be 4, so that's easy 4. So this can't be 4. So if this is 7, this is 1, 6. So if this is 7, this is 1, 6. This has to be 4. This is 4, and this is 1, 3. That seems valid. This is 1, 6. This could be 1 and 6, or it could be 2 and 5. Those both seem valid. If this is 8, this has to be 1 and 7. So this is 2 and 6. Hold up. If this is 9. So if this is 7. If this is 7, this is 4. This is 1, 6. This could be 1, 6 or 2, 5. We don't know which. Oh, actually, we would know. Possibly. Hold on. Let's go through the possibilities. If this is 7, this has to be 1, 6. This would be 4. So this would be 3. This would be 1. So this can't be 1. Okay, well, yeah. So this could be 1, 6 or 2, 5. We don't know which. This is 4. This would have to be 9. This would be 8. This would be 4. This would be 3. This seems reasonable. So 1, 3. This is 4. If this is 8, this has to be 1 and 7. So 8, 1, 7, which makes this 7. So this would be 3. So this would be 2 and 4. 1, 7, 2, 4. This would be 3. This would be 7. So we had 7, 8. This is 1 or 4. This is 9. This is 1, 3 or 4. This would be 9 both times. That seems reasonable. So if this is 8, this is 2 and 6. And this could be 1 or 3. This could be 1 or 3. This is 1 or 4. This would be 8, so this would be 8, 3 or 4. That all seems valid. If this is 9, this is 3 and 6, which means this is 3. If this is 9, this has to be 1, so this is 3, 4. So that's 7. So you have 9, 3, 6. This is 7, this is 3. This is 2 and 4. So that works too. And this would have to be 4 and 5. Okay, those are all valid. Huh. Okay, so what about these? What are these possibilities, right? If this is 1, 7, this has to be 1, 7. Up to 2, 9. If it's 2, 9, this has to be 4, 7. So this is 1 or 4. This has to be 1 or 4 because this is either 8 to 11. And there's no 5, 6 possible. So this is 1 or 4. This is 1 or 4. This cannot be 1 or 4. This cannot be 1 or 4. So this is 5, 7, or 9. There is no 3. Ah. This can't be 3. This can't be 3 either. This can't be 3 because either that's 3 or that's 3, so that can't be 3. This can't be 3 because we know the 3, this is a 1 to 2 ratio, 1 to 2 ratio. So this can't be 3, this can't be 3. This is the only place for 3. So this has to be 3. This is 1, this is 3, which makes that 9. This can no longer be 3, so it becomes a 2, 4, 7 pair. This has to be 5. This can't be 7, can't be 5, can't be 9, so this is 1. This has to be 3. So we have 2 and 4, which makes this 1. So this has to be 1, 6. And this has to be 7. So this is 4, 3, 1. This is 4, this is 8, this is 4, this is 3, this is 7. This can't be 7. So no 4 or 7, no 4 or 5. So this has to be 1. And it's with 7 or 9. This is 7 or 9. This cannot be 7 or 9. And it can't be 4 here. This can't be 1. This can't be 7. No 1, 3, or 7. So this has to be a 3 here. This is 2. This is 7. So this becomes 1, 6. This can't be 6. No 1, 4, 7. No 3, 4, 7. So this becomes 8, 9. This forces this to be 7. This is 6. So we know the 5 has to be here. This cannot be 5. This can't be 3. No 2. No 4. So this is the 5. This can't be 5 or 7. So this is 9. This is 7. This becomes 8. This is 9. This is 5, 2. No 5. No 6. No 2, 4, 5. No 2 or 5. No 2, 4, 7. No 1, 6, 7. No 1, 6, 7 here. This is 4, 5. So this is 7, which adds up to 7, which adds up to 7. This is 14. Yeah, so this is 9 plus 5 is 14. So 7 plus 5 is 12. So this has to be 2. So we got this is 2, this is 4, this is 4, this is 2. This has to be 5 and 8. So this is 2. This is 1. So it has to be 1 and 9 because it can't be 1 and 7. So this is 9, this is 9, this is 8, this is 2. So this adds up to 10, which means it's 4 and 6. So this is 1, 6, 1, 3, 4, 5, 4. This is 7, this is 5, this is 8. This is 7, and we have 3 and 5. And that's it. Hope you enjoyed the solve. It was pretty clever. Kind of felt like it was a lot of busy work later on, but it is what it is. And I hope you enjoyed. I'll see you next time on Frank Puzzles. Take care.